Hello everyone, my name is Rahmaningrum, and in this video I would like to present my paper, Stochastic Dominant Applications on Lognormally Distributed Stock Return Data. Let me introduce my lecturer, Mrs. Subanti, as the first author, and I am as the second author. The fact mentions that nowadays investing in stock market is the most popular type of the investment. First thing that's come into our mind when we are talking about investing is, wow, it is very difficult word with many charts and numbers that difficult to understand, right? However, the problem that we have to solve is how to make a profitable investment. Recently, our government is trying to foster public interest in investing so that the economic growth will be increased. At this present time, we know that a lot of activities are disrupted due to the coronavirus outbreak. So what we have to learn from these situations? The answer is we have to be more considerate of any probability that might be happen. In this case, when we investing in stock market, we have to consider the movement of stock prices. The real problem that investors have to face when investing in stock market is how to gain return and avoid risk. An investment can be said to be successful if it can be able to optimize profit and reduce the possibility of loss. Investors have to make decision whether to buy, sell, or hold the stock. Investors also need to choose strong stock due to the uncertainty conditions. Meanwhile, there is a method that can help investors in making investment decisions, that is stochastic dominance. Based on the explanation before, the aim of my paper is to apply stochastic dominant method on stock return data with the assumption that data comes from a log-normally distributed populations. Many of us are still unfamiliar with what is stochastic dominant and what this method is used for. Based on Heyer in 2001, stochastic dominant criteria show the dominations between two different stocks based on the utility functions without requiring any distribution assumption. Although that stochastic dominant does not require any assumption of distribution, but the research for Kosmanen in 2004, a parametric approach can be added to HD criteria by assuming that the return data follows a particular distribution, therefore more relevant results are obtained. Previously, the normal distribution have been applied to SD method, but it has the disadvantage of not being able to represent the stock prices because it implies that the value of stock prices can be negative. So in this research, we use log-normal distribution that positively skewed, therefore it is well-established distributions to represent the stock prices. The data used in this research is daily closing stock price data of 10 different indexes listed in Indonesia Stock Exchange, and we use the period of October 1st, 2020 to January 30, 2021. Therefore, 79 data for each stock indexes. There are 5 steps of analysis. The first one is collecting the data, and then we calculate daily return data so that we can calculate the logarithmic of the returns. After that, we testing the normality using JKBIND, and then we apply stochastic dominant criteria with log-normal distribution approach in indexes that follow log-normally distributed populations. Let's begin the analysis process. The first step is we calculate the return, and return is defined as rate of profits. Return can be calculated by reduce the value of stock prices at T period with the value of stock prices at period T-1 and divided by the value of stock prices at period T-1. For example, in calculating the return value, we have the closing stock price of Jakarta Islamic Index 70 in January 30, 2021 is 630, and the closing stock price of Jakarta Islamic Index 70 on January 4, 2021 is 646. So by using the equation before, we can calculate the daily return, that is 0.0252. And in the same way, we can calculate all the daily return of each of stock indexes. After calculated all the daily return, so we can testing the normality using JKBIND. There is a test based on skewness and kurtosis based on Gujarati in 2004, and the equations to calculate the JKBIND normality test show in the slide of the presentations video. As an example, we have hypothesis null that the logarithmic value for the returns of JKII comes from a normally distributed populations, and we use the significant level is 0.05. So the rejection of H0 is if the value of JKBIND is greater than the G-square value, and using the equation before, we calculate the JKBIND value for Jakarta Islamic Index 70 or JKII is 0.9. So the conclusion is H0 was not rejected, and it can be interpreted that the logarithmic value for the returns of Jakarta Islamic Index 70 comes from normally distributed populations. The additions of the log-normal distribution assumptions to the stochastic dominant rule emphasizes of the return calculations, and then the dominance criterion is expressed in the form of log-normal distribution parameters, which are mean and variance. There are two theorems of stochastic dominant with log-normal distribution. The first one is first order, and the second one is second order. And then the rule of the theorem is shown as in the slide of the presentations, and in this case we just only apply that the stock indices are fulfilled, that the value of stock return follows a log-normal distribution populations. We applied the first order criteria, and for an example, we have two different stock indexes that are JKMING and JKCONS with hypothesis null, that mean value of JKMING are smaller and equal than JKCONS, and we use significant level of 0.05. We can calculate the test statistic of JKMING and JKCONS that are 2.12, and the conclusion is H0 was rejected. So these combinations of two indexes meet the first constraint of the first order criteria. Then we testing the variance with f-test, and the hypothesis null that variance of JKMING is equal than JKCONS, and the test statistic or f value is 10.45. So we can conclude that H0 was rejected, and can be interpreted that don't meet the constraint of first order criteria. And then after that we can go to the second order rule. The second order criteria of stochastic dominant with log-normal distribution are shown in the slide presentations. We have to calculate the expected value of stock return, and then we calculate the coefficient of C value. After that, we can decide whether it is fulfill the second order or not. As an example, we use JKMING and JKBIND. The expected value of JKMING is greater than the expected value of JKBIND, so it is fulfill the first constraint of second order rule. And then the value of C coefficient of JKMING is smaller than the see coefficient value of JKBIND, and it can be concluded that fulfill the second constraint of second order stochastic dominant. And in this calculation we can conclude that the constraint was fulfilled so that the stock combinations of JKMING and JKBIND meet the criteria for second order stochastic dominant with data assumes to follow log normal distribution. With the same procedure, we applied to all stock combinations, and finally, we can conclude that there are 3 stock combinations that dominate on FSD or first order stochastic dominant criteria, and 41 stock combinations that dominate on second order stochastic dominant criteria with data assumed to be follow log normal distribution. With the same way, we can apply this approach to other indexes, other data, and when investing, we can use this approach too to make the best investment decision. We can invest in stock which are dominated in first order or second order and others criteria. So with the expectations that our portfolio is more profitable. Of course, it's not 100% can be successful, but at least we can use historical data for considerations when we invest in the stock market. That's all for my presentations. I'm so sorry if there are many mistakes. That's all for me, and thank you for your attention.